Okay, so we have a quiz on Wednesday, and one of the questions is Pythagorean identity. So this is a perfect thing for us to go over. First thing I notice is that sine is a negative number, so that means I have a negative y. And then this says cosine is less than 0, so that means I have a negative x. Negative x and negative y mean quadrant 3. Okay. Well, okay, there's my setup. There's my labeling. I've got quadrant 3. Okay, there's my Pythagorean identity. Shh. Okay, so let's talk about what I did here. First thing was I have a negative is a positive. Then I squared the 2 and squared the 3 separately. And then 1 squared is 1. So I changed that to be 9/9 to have a common denominator. Are you guys okay with those? I didn't show my work for the 1 to 9/9 part. But you guys all see where this came from? You sure? Okay. Okay. Then I square rooted both sides, remembering my plus and minus. And then I square rooted both pieces separately. The 3 comes out nice, but the 5 does not. Good so far. Yes? Okay, now details. On your test, a lot of you guys left the answer as x equals. The plus or minus, I think, was pretty good. A lot of people drew it in the wrong quadrant, but most people chose the correct one. But you should take the x and change it to cosine for your final answer. So cosine theta equals, and in this quadrant 3, we want the -1. So negative root 5 over 3. Okay, now this particular problem also asks us for tangent. The one on your quiz on Wednesday also asks you for tangent. Okay, so there's just a little reminder, tangent is y over x. Okay, and y is -2/3. And x is negative root 5 over 3. Any questions about where I got those things from? This is not the time for whatever that is, Connor. Okay, now what's next? Something happens in all of these problems. Beautiful. Denominators cancel and yeah, you're amazing. You already know what I'm going to do. But I just want to mention the negatives also cancel on this particular problem. And I rationalize. And final answer is 2 root 5 over 5. Okay. Any questions on number 1? We got it? Number 1? Okay, moving down to number 3. Number 3 is not on your quiz on Wednesday, but we need to get better with negative angles. Notice I threw all negatives in this. So for this, I'm going to do 0, negative 180. And I'm going to put a little arrow down this way to remind me that negative angles go in that direction. Okay, so 0, negative 90, negative 180. So negative 110 is going to be a little bit past negative 90. Okay, draw an angle with the given measure and standard position. Done. Find the reference angle. That's next. The reference angle is the difference between these two. And I don't do any kind of fancy subtraction. I just noticed that there's 70 there. Can you guys tell that there's 70 between 110 and 180? What? Okay, excellent. Is it a good day? Okay, and then the directions say, and the positive angles with that reference angle in all 4 quadrants. So I'm going to take my straight edge and extend the lines way too far, apparently. I don't know why I made them so big, but it's fine. Okay, so this is 70. That makes this 70. Notice this is 20 away from here. So what's this going to be? 110. Okay, now this is going to be 180 plus 70, which is 250. And then 290. Okay. Now can you guys find your notebook, please? And thank you. We need to finish 10-1 through 10-6. And then we're going to come back to the escape room and talk about that. Okay, go ahead and set up those 2 things there. All right, guys, so, we left off with Uncle Zachary and Angela being super lucky and her uncle saving money for college, blah, blah. Okay, number two. Angela continued to think about Uncle Zachary's savings. Angela wrote the equation for the sequence as T of n equals 47 plus 3n. Okay, real quick. Ours was 3n plus 47. Those two are the same thing, right? 47 plus 3n and 3n plus 47. Everybody clear? Those are the same. Okay. Just making sure. Uncle Zachary wrote his equation as T of n equals 3 times n minus 1 plus 50. Okay, we're going to write that right under here. So T of n equals 3 times n minus 1 plus 50. Okay. Is this also the same thing as this? Think about it before you answer. Is this the same thing as this? Okay, so if I distribute, this is 3n minus 3. What's negative 3 plus 50? 47. Okay, this is called writing the equation in terms of term 0. So the one we did yesterday, not yesterday, Friday. And this is called writing the equation using the first term. Okay, they have their pros and cons. Term 0 is easier to plug into. But term 1 is easier because you don't have to find T0, which isn't a big deal when you're talking about 50 and 47, but sometimes the numbers are really bad, and it would be really nice to not have to work backwards to find term 0. Okay, now in B, we are supposed to figure out how much Angela got in her first year. Do you guys trust me to add up all of these things without like sitting and adding them all up, just for time purposes? So I'm going to write it like this. I'm going to write 50 plus 53 plus, and then dot, dot, dot plus 83. So that's just my little, like, my pattern is continuing dot, 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 but I'm too lazy to write it. Okay, so her uncle saved her $798 in her first year. And now she wants to find out how much she has total mathematically. I don't know why she's not just checking her bank app, but that's fine. And to do that, I'm going to give you a history lesson. Write this word right here. Just trust me. History, Gauss. His name is Gauss. What? History? Yes, indeed. Yep. Here he is. His name is Carl Friedrich Gauss. And he was born in 1777. And this is the guy I was telling you about, the super naughty genius. Naughty genius. Okay, so everybody knows that kid, right? No, we don't. I don't know if we have that kid anymore. They're just like super ridiculously smart, but just cannot control themselves. Okay, and now I gotta be honest and tell you, I don't know what kind of materials they were working with in the late 1700s, but the story goes that Carl Friedrich Gauss's teacher was annoyed with him because he would finish all his work really fast and then drive everyone crazy. Okay, I'm thinking like super smart Bart Simpson here. This is what I picture, but like in that outfit. I don't know. Okay, anyway, so okay, so the teacher thinks that, and I'm assuming it could do because it's the 1700s, he thinks that he's really smart and he tells Gauss to go back to his desk, table, don't tablet, and add up the numbers 1 through 100. No, 0 through 100. Okay, well, let's say 1 through 100. Okay, so Gauss goes back to his table, desk, stool, and gets out his tablet, chalkboard, papyrus, I don't know, and comes back like 30 seconds later, and the teacher's like, how did you do that? Because the teacher really thought that, he bought himself some time. Okay, and this is what Gauss did. So just watch. Okay, so this dude. Okay, what he did was he said, okay, he wrote this down. 1 plus 2 plus 3 plus dot 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 plus 100. So that's the problem that he's solving. And then he said, what if I write it backwards? Then add all of these columns together. Okay, what would be the total of the first column? 100 and what? And what would be the total of the second column? And the third column? And the last column? Okay. No. So Gauss says, okay, if I add all these up, I get 101. How many times? I don't want a plus there. I wanted a times. How many times do I get 101? How many columns are there? Okay, you got to think more with your imagination. Including the dot, dot, dot. 100. And then
The last term is 100, right? So I mean, it went all the way up to
okay, and then he said, I got to take this answer and divide it by 2 because I actually had it written twice. And this comes out to be 5,050. And this is the formula that we use to add up arithmetic series for everything. Okay, so the formula that we use looks like this. Sum equals n over 2. I'll explain what these symbols mean in a second. So n is your number of terms. In this case, there were 100 numbers, so the number there would be 100. This is term 1. And this is term n, which is the 100th one or the last one. Okay, so let's think about that in terms of Gauss's problem, and then what we're going to do Angela's savings. So how many things are we adding up? 100. So there's your 100 over 2 right here. And then what's the first number he's adding? 1. And what's the last number he's adding? 100, and that's where your 101 comes from. Okay, so let's do Angela's savings. Okay. How many months did he save for her? It's up in your notes in number 1. $216 months, all the way through her 18th birthday. Okay, so that's over 2. Okay, and what was the first amount that he deposited? 50. And what was the last amount that he deposited? It's also back in your number 1. Not in the first year, her 18th birthday. 695. Okay. So 216 divided by 2, parentheses, 50 plus 695. He saved for her $80,460, and that's without interest. So pretty good. What a nice man. Oh yeah. Can you imagine having the kind of brain that can come up with that stuff though? I just don't have it. I don't have it. I can follow directions, I just can't make them.
How would you guys be going through it? But,
Hmm.
you get the car?
No, people never wrote us back with a time.
$300.
I didn't get
Yeah.
scammed. I just didn't purchase anything. I'd be really upset about losing $300. Okay, but see, now I'm in the position where I'm gonna get the deal because like if somebody posts something on a Saturday and then the bank's not open past noon, but I have the cash out from the last one, I'm ready. Well, this is when it's gonna happen for me. Anyway, okay, number 4. We have a lot left, lot left. 4 and 5 are extremely easy. 6 is a little bit more spicy. All right, let's do this. So, um, some people are formula people, some people are visual people. And in this one, what we're going to do is take a look at a visual representation of how to add up something like this. So can you guys see, take a look at the graph. We're not gonna do everything that CPM wants us to do here, but I want you to take a look at the graph and understand how this matches the sequence that you wrote on number 4. So it's like 1 plus 3 plus 5 plus 7. Can you see it?
Yeah.
Okay. So this little graph is going to help us visualize Gauss's formula. And the formula is fine, but visuals are always good too. Okay. The first thing we're going to do though is practice writing the equations for this. So we're going to write both. We're going to write term 0 and the first term. So T of n equals, what is the growth in this problem? 2. 2n. And what would term 0 be? -1. Notice I wrote it in a different color on purpose because it doesn't actually exist in our sequence. It just is B. Okay, so that's how you write it in terms of term 0. And this is how we taught you in math 1. Okay, and now we're going to do the new one, which is kind of the lazy one. So you write 2 for the growth. And then you write n-1. And then instead of term 0, you write term 1. It's a little lazy because you don't need to go back and figure out what term 0 was, but these are the same thing. Okay, now 1 plus 3 plus 5 plus 7 plus 9 plus 11 is 36. Okay, really quickly, this is the perfect time for me to go over the difference between two vocabulary words that sound the same but are completely different. Sequence, commas. The first thing you wrote was a sequence. Series, pluses, is a sum and has an answer. Okay. Sequence, comma, a list of numbers. Series, pluses, and has an answer. Okay. Now, we're going to, in C, go back to the graph, and we're going to talk about the definition of these two things. What are the terms represent? How are they represented in the graph? And by the terms, I mean 1, 3, 5, 7, 9, and 11. Those are the terms. How are they represented in the graph? Heights, right? They're the heights of the bars, are they not? Okay. Are you guys overthinking it? Okay, each of the terms are the heights of the bars. So the bar was 1, and then the next one was 3, and the next one was 5. Okay, now the series. Where's the 36 going to come from the graph? Okay, so there's a bunch of different ways you could say it. The number of squares or the total of the heights. I'm actually going to write the area. The area of the bars. That's what I'm going to write. Okay, now for D, this is how we're going to relate it back to Gauss. For visual people, and those of you that you do Tetris, this is a Tetris problem. Can you visualize taking this guy, copying and pasting one of him over here, flipping it over, and scooching it? Yeah. Okay, so that's kind of what Gauss's formula is saying. Gauss's formula is saying, why don't you just take this, make a copy of it, turn it over, and make it into a rectangle, and then divide by 2, because we only had half of it. Okay. Yeah. Okay. So if I did that, what would the base of the rectangle be? Try to visualize it. 6. Okay, now this is the hard question. What would the height be? Nope. 12. Okay, so what is 6 times 12 divided by 2? Because there's 2 sets. Big giant hit. Okay. Okay, now for A, write the formula just so we have it. Sum equals n over 2 first term plus last term. Okay, this one right here, number 5A. How many terms are there? 7. Okay, so you guys write 7 over 2. And what I mean by that is this right here. There's the formula, 7 over 2. Okay, now what is the height of the first bar? 5. And what's the height of the last bar? 5. Okay, so this is 10 times 7 is 70 divided by 2 is 35. Okay. Do you guys get what I'm laying down here? We're not going to write the formula again. We're just going to look at the picture. Okay, B. How many bars are there? 16. Okay, so write on your paper, sum equals 16 over 2, parentheses. What is the height of the first bar? 4. What is the height of the last bar? 10. Are we getting the hang of it? Okay, let's see. 8 times 14. 80 plus 32, 112. Okay, C. Sum equals. How many bars are there? 6. 6 over 2. What's the height of the first bar? 228. What's the height of the last bar? 48. Nice. Do you guys trust me to add this up on my own? Is 3, 276 times 3, 276. It'll be 18 plus. I don't know. It's 828. I just glanced and cheated off my notebook from last year. No, I'm not. I cheated off my notebook from last year. Okay, last one. They tried to make this a little spicy. See if it tricks you. D. How many bars are there? 32. Do you see where the 32 came from? Mm-hmm. Oh man. Okay. What's the height of the first bar? 14 plus 20. Oh no, I already looked at my notebook. Okay. Those are all baby ones. Too much time on the baby one?
I said, I thought you've been in class for a while, so.
I'm sorry. Okay. Last problem, and we're gonna do several of them. They're not easy. These are not easy. This is where it turns spicy. You know how like in math, you're in the first part of the chapter and you're like, yeah, this seems so simple. And then at some point they drop the boom on you. Yeah, that's right now. Okay, so number 6A. You know the first term is 18, the last term is 72, and the common difference is 4 points. This is actually easy, but we need to translate. Okay, so it says, you know the first term is 18. So you write it like this. T1 equals 18. You know the first term is 18. the last term is 72. You write T of n equals 72. And the reason you're writing n is because you don't know how many spots out it is, but you know it's the last one. And the common difference is 4.5. That's D for the growth is 4.5. What is the series? What is the sum? Okay, so we can start by getting the series. So 18 plus 22.5, right? Because they've got to go up by 4.5. Plus 27? No. Yeah. Plus a lot of numbers that I'm too lazy to write, but I know the last one is 72. Okay, there's my series. All right, now I need to find the sum. Sum equals n over 2 first term plus last term. Okay, what can we plug in here that we know already? Beautiful. Okay, so we have sum equals, we don't know how many numbers it is. That's okay for now. 18 plus 72. Okay, how do I find out how many numbers it is? I need to find the equation. Every time you have something missing on one of these, you go to the equation. Do you guys want to write the equation in terms of the first term or term 0? For what? Okay, do you want to write it like this or like this? First one, okay. They'll both work. T of n equals 4.5 n plus, and then I gotta 13.5, yeah. Okay, now I want to find out which spot 72 is. So I take the 72. Mm-hmm. What? Because that's the n is the spot, T of n is the term. Let me go back to, yes, this is Fridays. N is the spot, T of n is the term. I don't want to know what number is in spot 72. If you're feeling ambitious, you could just list out the whole thing till you got to 72. I don't suggest it.
Oh, yeah, nothing wrong with that.
It depends on the size of your writing.
Yes.
Okay, and then your sum is 585. If you do not get a positive whole number here, you know you've done something wrong because this has to be a positive whole number. Okay, so number one rule, if you get stuck and you're missing a piece, go to the equation. If you're stuck and missing a piece, what do? Equation. Every time. Equation. Okay. We're doing two more, B and D, and then we're gonna talk about the escape route. Okay, B. You know that there are 6 terms. Write down n equals 6. The last and smallest term is 21. Write T of n. Actually, no, write T of 6 equals 21. And the sum is 336. Find the series. Okay, so it said there are 6 terms, so I wrote n equals 6. It said the last and smallest one is 21. I knew that it was in spot 6. And then the sum is 336. Okay, let's see what we can do. So we know we have 6 spots. We know that the last one's 21. We know it adds up to this. I'm going to start with the sum formula and see where I get. So sum equals n over 2 first term plus last term. Okay, the sum is 336, so I'm going to plug that in there. N is 6. First term I don't know, but I would love to find out. And the last term is 21. Okay, now as far as algebra goes, what does your brain tell you to do? Does it tell you to make this into a 3? Okay. And then does your brain tell you to divide by 3 or distribute? Divide? Okay. Either one's fine. They'll all get you the same place. Okay, so I know that 91 is the first term. I know that 21 is the last term. I know there's 6 spots. How much do they go down by? You don't know. What do you do when you're stuck and you don't know? The equation. Beautiful. Okay. So on this one, should we write it in terms of term 0 or term 1? Do we know term 0? Can we find this? No. Now you don't have any choice. Okay. So what is the last term? 21. How many terms are there? 6. And what's the first term? All right, so 91 minus 14, 77. Minus 14, 63. Minus 14, 49. Minus 14, 35. And then 21. One. You know that the third term of an 18-term series is 29. Okay, we need to be really careful when we write this. You know that we're doing D, by the way. You know that the third term of an 18-term series is 29. Okay, so I'm going to write n equals 18 because it says there's an 18-term series. And the third one is 29. And then it says the terms are increasing by 10. What letter is that? B. Okay, let's try to do this. Sum equals n over 2. Oh no. Cripes. I don't know the first term or the last term. What do I do when something's missing? Equation. Okay, now on this one, to be honest with you, it might just be easier to find the first term instead of with algebra just counting. So if they're going up by 10, then this would be 19 and that would be 9. Okay, so we have sum equals 9 times 9 plus, and then we need to figure out what this is. Okay, now this would have been totally fine if you wanted to get term 0. If there's just a point where I get too lazy and I just use the first term all the time. I don't know. It's just me. I like to use the first term because I'm too lazy to count backwards. But whatever you like. You could have put -1 here without the parentheses. Same thing. Okay, now which one do we want? What spot do we need? How many spots out is this, the last one? 18. Okay, that's done. Can you guys find your escape room stuff? And thank you. Which ones of the escape room would you like me to go over? There's a couple of really spicy ones. I think one of them's really spicy. Not even really spicy. It's just kind of spicy. Some of them are easy. Some of them are, anyway, what can I help you with? Yes, honey? Not, nothing? You don't want 10? Okay. So 10 requires multiplication. I don't know if you're trying to add them. But it said for number 10, there were, hold on, there are 18 boys and 17 girls. The teacher wants to select 2 boys and 2 girls to represent the class. Okay, so first of all, they're both the same, so it's combinations. Does that make sense? Okay, and you do a separate one for the boys and a separate one for the girls and multiply. So there's 18 total boys and you want 2. And then there's 17 total girls and you want 2. And I got 20,808. So the moral of the story is, I guess, when there's 2 different sets, you have to multiply them. I think is probably what your question was.
I didn't do it, but you guys talking about 2-9, like it was really hard.
Clue 9 is the hardest.
Yeah.
Yeah, we have time. Did anybody get clue 9? I think clue 9 was, yeah, nice. Good job. Okay. Clue 9 is rough. It says a drama teacher needs to arrange 6 students in a line so that 2 students are always next to each other. Okay, so I have to get the pens. It's just the only way to learn this for me was pens. I actually had to get the pens out because I'm dumb. So, okay. So let's pretend that these 2 guys have to be next to each other, right? Okay, if these have to be next to each other, there's really only 5 options for moving them. Okay, so just pretend these 2 pens are glued together. That means that there's really only 5. Okay, so you have 5 and you're arranging 5 because they're different. But then that doesn't really work because what if this is like Billy and Susie? And what if Billy and Susie stand this way? So it could be Susie Billy or it could be Billy Susie, which means that there's 2 sets of options for each one. So times 2. Now, Mr. Knight did it this way. He came over and I was like, is there an easier way to explain this? And he took 2 of the pens and he said, okay, 1, 2, 3, 4, 5, flip. 1, 2, 3, 4, 5. Then moved it here. 1, 2, 3, 4, 5. Flip. 1, 2, 3, 4, 5. And then you move this pen here. 1, 2, 3. You get it. That's where the 5 permutation 5 comes from. And then could be this way or this way. Rough. All the rest of them are pretty decent though. Once you get the thing that Michaela asked about and number 9, it's not bad after that. Okay, hold on. We updated this. So this is the total number of days total, which needs to go down 3, and that needs to go down 1. 15 and 19.
Yeah.